Okay. Yeah, determining whether it was disk or washer method. Okay, so let me draw a bunch of scenarios, and then you can tell me whether you think it's disk method or washer method. But a quick review of how to tell disk method versus washer method is look at the dotted line in relation to your shaded region. If your dotted line, if your axis is up against the flat surface of your shaded region, then that's the only time that you're going to be expecting disk method. Okay. If your dotted line is up against just a point, but not touching every part of the graph, like if it's up against a curved region, that is still considered washer method. And obviously, if it's not touching at all, is washer method. So, okay, let me draw a couple of scenarios here, see what you guys think. All right, so let me just do 3 scenarios here. First scenario, okay, we have a kind of a parabola looking region with a horizontal line, and it's rotating around this axis. All right, so what do you guys think about number 1 here? Disk method or washer method?
Mr. Yang, for some reason on my screen I can't see like the work.
I'm not. I guess maybe I'm not sharing. My bad.
Okay.
Thank you.
Okay. Sorry.
Thanks. Appreciate it. All right. Sorry. All right. There we go. Yeah. See it now.
Yeah, I can see it now.
All right. So first one. Daniel, I think you were asking about this. So do you want to try this one? What do you think number 1 is? Disk method or washer method? Good, good. Yeah, washer method. Yep. Right. Touching is not good enough here. We need washer method. So if I want to, that means we're drawing 2 radius, right? So the radius is going to extend from the axis to the furthest boundary. That's big R. And little r is going to extend from the axis to the closer boundary. That's little r. Yeah. All right, what about number 2? Yeah, this method. Yeah. There's no gap between the axis and the shaded region, and we only need one radius, big R. All right, how about number 3? Yeah. It doesn't matter if it's touching or not. It's a curved surface, so regardless of whether it's touching or not, it's going to be washer method no matter what. Okay. So axis to the boundary, axis to the boundary. All right. I haven't made the key yet for review worksheet 2 tomorrow, so do you guys want to work with me and get a head start on tomorrow's worksheet?
Sure.
All right, so I already have this on the website, so you can access it, or you can just copy it down on a sheet of paper. But we'll work through it together. All right, so let's see here. We have f and g are functions given by 1/4 sine pi x. That's the f of x here, so it's going to be the graph that kind of has a parabola shape here. So this is my sine function here. 4 to the negative x, that's the curve that's sloping downward here. That's my g of x function. R is the shaded region here, and S is the shaded region to the right. We're going to find the area of S. So area of S, we can just simply do top minus bottom, right? So I'm just going to do a rough sketch and just look at region S. Okay, top minus bottom. And we do need to plug into the calculator so we can find these intersections, right? So practice with that. Make sure that you're in radian mode. I'm just going to put 0.25 for 1/4 plus sine of if I do zoom 6, yeah, it looks like it's all within this mess here. So I can trace, sorry, zoom box. So I'm just gonna put a box around this small region here. Well, it's having trouble here. Yeah, so those are the two intersections I'm looking for. So second trace, intersect. Choose a point here and that's going to find that intersection for me. 0.178. Okay, so I found that before here. The other intersection here, second trace, intersect, scroll over to enter, enter. So we're looking for X values here, so 1. Okay, who here has a 36 Pro? Okay, I'll show that step as well. Emily, you have a graphing calculator?
Yeah, I use the TI-84.
Okay.
And the other day, I'm trying to remember which question it was. It was like y equals the square root of like x minus 2 and y equals 7 or something for one of our problems. I put it into my calculator and I checked it like 3 times, but the graph wasn't the same as the one that came up like on yours and on the one on the sheet we were doing.
Okay.
Do you know like why that would like happen?
Let's do this. If you can you try resetting your calculator just in case there's something that that we're unable to.
Yeah, probably. Because I also had this problem today where like when I click graph, it says the variable's not defined, and I don't really know like.
Yeah, there may be just over time you may have entered in something for other situations and it didn't get cleared out or something. So
Okay.
here's where you can do it. If you go back to your home screen and then do second plus. You see that memory button there, second plus.
Oh, is it memory management and delete?
Yeah.
Okay.
And then you're going to go to 7.
7, all right.
1 and 2. So 7, 1, 2.
Oh, wait a minute. Mine just changed actually. Second plus.
Yeah.
Management. It's a little bit different on my.
Okay. Do you have a reset?
Yeah, I could just do 1 and that's all. Or
Yeah, 1.
Okay.
And then 2.
Oh boy, it's different on the graphing calculator. It's being weird.
Is it the same option?
No,
Oh.
Here I'll show you actually. Let me turn this on. I can go down to memory management and delete, but I don't know if you could see.
Oh yeah, okay, yeah, hit all.
Okay, and then
What's your option after that?
I installed games on my calculator, but
okay.
that's what comes up there.
Never mind then. I don't want you to delete all that if you don't want to. That's fine.
Yeah. Oh, there's REM. I mean, I don't really care. I don't use them, but I don't know. I'll just probably look at a YouTube video.
Yeah, I'm not sure why Yeah, I'm not sure why or how to, or why your screen looks different from mine.
Yes.
But
bit annoying.
okay.
I do have a what's it called? The other calculator that we use.
You have this one here. You have the 36.
Yeah. So if worst comes to worst, I could just use that one.
Okay. Well, I'm about to show how we can do it with that as well.
Okay. Thanks.
So, all right. So Danny, you're asking about this as well. Make sure you are in radian mode. And we're going to go to second num solve. So second sign. So second sign will take the num solve. On the left side, I'll put the 1/4 plus sine pi x. And on the right side, I'll put 4 to the negative x. Hit enter. So I want to target this x value first, right? So I know that this x value is closer to 0, so I'm going to hit 1 or hit 0. So it's going to look for the intersection that's closest to 0, and it should target that point for us. Enter. .178. Okay. Now, it's only going to find one intersection, so you're going to have to give it another starting point to find that intersection. So you may not know that this is 1, but you can start, just go to a point that's further away, and when it comes back to it, it's going to hit 1 before it hits that one. So maybe if you want to start at 2 or 3 or 5. Oh, maybe it won't go that. So maybe we'll start with 2, right? Start with 2, see if it'll work its way back to that point here. Hit enter. Oh, 1.94. Okay, so yeah, that's one of the restrictions with the 36 is that you don't know exactly where you are along this path here. So what you can do is, you know, these are pretty small values, so maybe you can just go at increments, maybe 0.5, and see if it'll find that next value for you. Yeah, it's still sitting at 0.178, so let it go to 0.7. There we go. Okay, so now it found it for us. Right, so you know it's going to be relatively small value, but you want to be able to get a little far enough so that it'll pick this one instead of this one, right? So if it's not far enough, it's going to revert back to 0.178. But we have our two x values there, 0.178 and 1. Okay, so now we can find our area. Area is just top minus bottom. The top is going to be the sine, and the bottom is going to be the 4 to negative x. Okay, so we're extending from 0.178 to 1. Okay, so go ahead and plug that in. I'm just going to call these functions because I have it stored under y1 and y2. Math 9. Okay. top function minus parentheses bottom function. Excuse me. .410. Do you guys get that?
Yeah, I got that.
Okay, thanks. All right. Area R. Excuse me. Sorry. Is that little region here.
Can I just ask a question really fast?
Yeah.
Would we have to put units for this for area or not necessarily? Because there's no like units, sort of.
Yeah, good question. You don't have to. If the problem doesn't specify units, then you can't. You're not going to get points taken off.
All right, thank you.
But maybe for now, I'll just put unit squared, just as a constant reminder that this is different from volume. But yeah, no issues if you don't do that. All right, so we have region R. Again, I like to do top minus bottom if possible. But do you notice anything different about top minus bottom for region R?
The domain?
They flip, right? The top is the 4 to the negative x. And the bottom is the 1/4 sine plus pi x. Okay, and where are the bounds going to be? From where to where?
Would it be from 0 to 0.78?
Yeah, that's what I got. Sorry, write that a little clearer here. So top 4 to negative x minus the bottom parentheses. Okay, now parentheses is going to be important here. Otherwise, we're going to lose track of the negative sign. All right, so I have 4 to negative x stored under my y2, but if you want to put it directly in, that's fine. And then parentheses y1, which is my 1/4 sine phi x. All right, did you guys get that?
I got the same answer again.
Okay. All right, rest of you guys okay?
Yeah.
Okay. All right, part C, find the volume of region when S is revolved around the horizontal line y equals -1. So y equals -1 is going to be down here, right? So that's going to be here. All right, so now we're rotating. So because of rotation, we have to decide whether this is disk or washer method. So what do you guys think?
Is it Washer method?
Yeah, washer method, right? There's no flat surface it's up against. We have all that gap with our shaded region. Okay, so we have to draw two radius. Remember, this looks like the edge of the diagram, but this is really the center because this is going to end up rotating all the way to the other side. So we need to be able to draw the radius from here, right? And both will extend to the boundary of our shaded region. Okay, so here's my big R. And here's my little radius.
Mr. Yang, does it matter like which order you put the big R and little r in? Like,
no, it doesn't matter. But I'll just
Okay.
put them relatively close to each other so that visually it's easy to see which is big R and little r.
All right.
Yeah, the order is not going to matter. Just don't do this. Just don't connect between the two shaded regions. That is not going to be your radius.
Yeah.
Okay, good. All right, so big R and little r. I'm going to label everything here. So this is y equals -1. That's my AOR. This top one here is the 1/4 sine, or 1/4 plus sine. And then this graph here, this is the e to the -4x. Oh, sorry, 4 to the -x. Okay, I think we can build our two radius now. All right, top minus bottom. The top is sitting at the curve. Minus parentheses. Bottom is the -1. Clean that up if you like. 1/4 plus 1. The same thing as 1/4 plus 4/4, which is 5/4. All right, little radius. Top minus bottom. The top is sitting at the 4 to the -x. The bottom is sitting at the -1. All right. I think we have everything that we need to build our volume formula. X1 to X2, we're just looking at region S, so we're starting at 0.178 and we're going to 1. Okay, big radius squared. Minus little radius squared. All right, let's see what that gives us. I'm just going to update this here. 125. Okay, I'm just going to hold my big R and little r under y1 and y2, just so I don't have to enter in as much stuff. But you're more than welcome to enter everything in under one line. Just have to be careful with your parentheses. All right, can someone check my work here? What you guys get?
I got the same thing again, so.
Thanks.
I also have a quick question. So I have a TI-83 and a 36X Pro. I've just been using the 36X Pro to do the integrals because I was trying it on the 83 and it looks a little different than the 84. Like the.
Right. Okay, yeah, I'll talk about that. You probably have an older one. So
yeah.
If you're older one, you can still do it. Let me show you. You're going to do Math 9, but it's going to show you as FN integral.
Yeah.
And okay, I have it written before here. So It's going to take 4 arguments. You're going to put the expression that you want to evaluate. Let's say if it was, whatever you want to put in that first space, comma, then you're always followed by x. That's kind of like your dx. And then followed by your lower bound, followed by your upper bound. So try that. See if you're able to get the same answer.
Okay.
Joey, same thing with Math 8. Math 8 is n-deriv, which you can do on the 36 Pro, but on the 83, if you have an older 83, you can type in the expression that you want to find the derivative for, x for the variable, and then you want to, whatever value you want to enter into the derivative.
Okay, thank you.
Mm-hmm.
Okay, that really helps. I was just confused a couple of times. It was a little different.
Without that math print, it looks kind of strange.
Yeah.
All right. Others of you, are you guys doing okay so far? All right. Part D, enclosed region R is the base of a solid. The cross-section of a solid taken parallel to the y-axis. So we always have to decide what direction we're trying to build our base. So we're back to region R. I'll put region R here, make it a little bit easier to look at here. All right, so parallel to the y-axis. So here's the y-axis. Y-axis is vertical. Parallel means same direction, so still vertical. So our base is going to be vertical, so top minus bottom. Okay, but region R is a little bit different, right? Region R, the 4 to negative x is up top, and the sign is the one that's below. All right, so we're going to find our base length. Top minus bottom, 4 to negative x minus this whole expression. Big parentheses. clean this up. All right, now we can decide what area we're trying to build here. We're trying to build an isosceles right triangle with a leg on the base. So we go to our formula here. That's the 1/2 base squared. So we're just going to take what we found for our base and insert it into the base of our formula here. Now we can enter into our volume formula. This is a top minus bottom, so the volume formula for our cross section is just the integral from x1 to x2 area dx. Okay. Before, when we were rotating, our area was always pi r squared with circles, but now our area is going to be whatever we find here. So we're going from 0 to 0.178. Right? All right, math 9. To the negative x. Close parentheses squared dx. All right. Can you guys confirm? Are you guys able to get the same thing I did?
I got the same thing.
Okay, good. Thanks. And do we attach pi to our answer here?
I don't think so because it's not rotating.
No rotation, no circles. Only time cross section will have pi in it is with semicircles, but we're doing triangles, so no rotation, no circles. Yeah. All right, let's do one more. I have to go in about like 10 minutes or so, but I think we'll squeeze in one more. Number 2 here. Given the function region below, we have y equals natural log of 4 minus x. That's this curve here. We have the line x equals -1, and we have the x-axis. Find the volume when it's revolved around the line x equals -1. So x equals -1, that's over here. That's where our boundary is. All right, what do you guys think here? Rotation, so we got to make a decision. This method or washer method?
Disk method?
Yeah, up against a flat surface, right? Okay. So that means there's only one radius to draw, perpendicular from our axis, extend to our furthest boundary. All right, what do we have to be aware of when we're dealing with a horizontal radius?
You have to like get everything in terms of x.
Yeah, this is not the right form, right? If you're staring at whatever function is given to you, these are perfectly set up for top minus bottom, but not quite for right minus left. And we're forced to right minus left here because we have to rotate it, being with our radius being horizontal. So we have to rewrite our equation here. All right, so we're going to work with this equation. Y is equal to natural log of 4 minus x. All right, what can I work towards getting that x by itself? I can rid myself of the natural log by doing what?
Would you raise it to like base e?
Right, yeah, because we can, if we involve the inverse function, we know that they're going to find a way to kind of work towards and cancel each other out. So e to the y, e to the ln is just going to undo each other. The 4 minus x, which is going to drop. I should drop the parentheses too. So I have e to the y is equal to 4 minus x. If I just rearrange it, solve for x, add x to this side, subtract e to the y to the other side. All right, so that's my updated equation here. All right, I think we have everything that we need to build our volume or to build our radius here. Big R, right minus left. Right is the 4 minus e to the y. Minus the left. Left endpoint is that the -1. Combine some like terms there. I get 4 plus 1, which is 5, so 5 minus e to the y. Okay, we need to find that intersection between this graph and this here. So we need to set them equal to each other. -1 is equal to 4 minus e to the y. Or you can go back to your original equation and just plug -1 into the function here and solve for y. So I plug -1 to the function, I get 4 minus -1, which is 5, so natural log of 5. So that's the same thing as natural log of 5, which is 1.6. All right, so we need this value here. And the reason why is because we are stacking these cylindrical disks from the lowest to the highest y value, right? Because our volume formula is now going to be v equals pi integral from y1 to y2, right? If we're doing right minus left, we have to follow what the formula says. Y1 to y2, big R, or y squared for horizontal disk method. So from 0 to 1.61, big radius squared. I should put parentheses here. 5 minus e to the x, close parentheses squared, dx. $12.236. Do you guys get that? Pi units cubed. All right, you guys okay with that? Did you guys get that?
Yeah.
Okay, good. All right. We can pick up where we left off tomorrow. Tomorrow I may have a help session. Yeah, I'll have a help session tomorrow afternoon. So I'll send that out in a remind. But we got a head start on tomorrow's worksheet. So if you guys want to try finishing off the rest of this, you have everything set up already. Just continue working with the setup. So, all right, thanks guys. See you tomorrow.
Thank you, Mr. Yang.
Yeah, see you. Bye.
Yeah.
Thank you. Have a nice
Thank
day.
you.
Take care.